Hey everyone. So this is the last video of the 9-2 three-part video series covering, this one's going to cover the vertical motion model, which is going to discuss the idea of having an object that is following a flight path that looks like a parabola. So rather than having x and y, we have h and t. T for time, h for height. An object, like perhaps a baseball being hit or a soccer ball being kicked, those objects are going to have a starting point. Usually the starting point is off the ground a little bit. With the soccer ball, you would obviously be kicking it off the ground, but with the baseball, you would be standing up when you hit it, so your starting point would be above zero. In any case, the object is going to have a flight path. If it's a baseball, a soccer ball, it's going to go up and then it's going to come down, which is following an upside-down parabolic motion. And the main thing to note is that when you are working with these problems, at some point you're probably going to have to calculate the axis of symmetry, which is the halfway point in your parabola. If you notice, the axis of symmetry is crossing the t-axis at the value for time when the parabola is reaching its maximum height, which would be known as the vertex. So basically, when you calculate the axis of symmetry, you're going to be figuring out the time at which the object reaches its maximum point. That's a really big idea. The axis of symmetry is basically telling you at what time your object reaches its maximum height, which is the vertex. So let's look at an example. A child drops a pebble from a height of 30 feet above a lake. The function h equals negative 16t squared plus 30 gives the height of the pebble after t seconds. What is the graph of this function, and about what time does the pebble hit the water? Well, more importantly, the pebble hitting the water is what we're trying to get, but let's look at the graph first. So let's make an h and t axis, and we have a t table. You can see the xy table over there on the left, but in this case we're going to have x being t and y being h. So the value for t, or x, that would begin at 0, as you can see right there, and that is because it would not make sense to have negative time. You have to have positive time, so we will go with a 0, 1, and a 2. When you plug in 0 down here at the bottom, 0 squared is 0 times negative 16 is 0 plus 30, that's going to still be 30. And then when you plug in 1 squared is 1 times negative 16 is negative 16 plus 30 is 14. And then when you plug in 2, you get negative 34. Now, before we plot these points, let's just mark up the graph a little bit. So very easily you can graph 0, 30. That's the starting point of the pebble. That makes sense. It says in the beginning of the problem, the child drops a pebble from a height of 30 feet. 1, 14 is right there in the middle. And then 2, negative 34, well, that would be below the graph, very far down below the graph. But that point doesn't really make sense because you're not going to go below the level of water. So basically when you draw your parabola, it would only be half of the parabola, and it would be going down, and then it would end right about there. Ignore the little extra part of it that's kind of drawn there. So this is what the graph would look like, and as you can see, it is going to hit the water beyond 1, but not really at 1.5 seconds, just a little bit beyond 1 second. So that's what the graph would look like, and that's the answer to that part of the question. Next, the pebble hitting the water. That would be when the pebble has a height of 0. So what you can basically do is set the function equal to 0 and use inverse operations to solve. And the first inverse operation would be to subtract 30 from both sides. And then 30 minus 30, well, that would go away. And then 0 minus 30 would become negative 30. And then the negative 16t squared would just come down. And then you would divide both sides by negative 16, and you would get 1.875 t squared. We don't want t squared, we want t, so we have to get rid of the exponent of 2. And if you remember correctly, you would have to square root both sides to make that happen. So 1.37 would be about the amount of time it would take for the pebble to hit the water, and that's the end of the question. Again, we were asked when the pebble hits the water. And if it's going to hit the water, it's going to have a height of 0. So what we basically did was we set the function equal to 0 to make that happen. Now let's quickly look at this word problem. If you have to pause the video just to quickly read it, go for it. Basically, you have this function here at the bottom, and it is modeling the path of a t-shirt launch rubber band thingy that is happening at the halftime of a basketball game. So these dudes in the middle are going to be shooting a t-shirt into the crowd, and it's going to be following a parabolic shape. You know, it's going to go up, it's going to come down. So the function down here at the bottom, that is modeling the flight path of these t-shirts. It's asking us some questions about the t-shirts though. For example, how long will it take for the t-shirt to reach its maximum height? What is the maximum height? And then what is the range of the function that models the height? When it's talking about the range, it's asking you what is the lowest height to the highest height. And as you can see, first off, you can already answer that question about the lowest. All of the dudes are standing 5 feet above the ground. So that would be the lowest height that a t-shirt would reach. But let's explore the rest of the question. This one is going to be a little more involved, so the slide after this is going to cover a summary. This problem is going to get a little long, so if you do want to skip to the end to just look at the summary of what you basically do with these vertical motion models, by all means do that. So we have the function at the bottom, negative 16t squared plus 72t plus 5. And the first thing we're going to look at is how long until the t-shirt reaches its maximum height. Well, the maximum height would be the vertex, and the basic idea is that the t-shirt would go up, and then it would reach a maximum height, which would be found by the axis of symmetry, drawn right here in the middle, and then it would have its vertex being the maximum height, and then the t-shirt would fall. So let's find the vertex, or the axis of symmetry. If you remember correctly, the axis of symmetry formula is negative b over 2a. And when you plug in negative 72 for b, notice 72 is positive, so when you plug in negative b, that is negative 72. And then a is negative 16. So negative 16 times 2 is negative 32. This was gotten, by the way, from knowing standard form. I'm assuming you know standard form. If you need to go back to a previous video to look at it, then I guess you got to do that. So you plug in negative 72 and negative 32, you divide them, you get 2.25 seconds. So after 2.25 seconds, the t-shirt will be reaching its maximum height. So that is the first answer to the question. 2.25 seconds is how long it takes to reach the maximum height. So what is the maximum height? Well, we would figure that out by now calculating the vertex. And the vertex is the point that corresponds to the x value of the axis of symmetry. So if you plug in the axis of symmetry value, which was 2.25, plug that into the function, that is how you're going to now calculate the vertex. The axis of symmetry represents the x-coordinate, and when you plug it into the function, you will get the y-coordinate of your vertex. So when you do 2.25 squared over here, you multiply by negative 16, so on and so forth, you wind up getting 86 feet. If you need to ask questions about this arithmetic, you can do that in class. You get 86 feet, so that is going to be the maximum height that a t-shirt will reach. So now, what is the range of this function? That is asking you about the y-axis. How high does the function get? How low will it get? Well, as you can see, the lowest point will be 5 feet. And that is because we have these guys who are already standing with the t-shirt locked and loaded. So they are 5 feet above the ground. That would be the lowest point, 5 feet. And then if you also kind of look at the function over here, at time 0 before the t-shirt is launched, if you plug in 0 for t, well, basically you're going to be canceling out the first two terms, because anything times 0 is 0, leaving you with just 5. Very important idea here. When you are plugging in 0 for t, you are basically calculating the y-intercept, which is the starting point in all of these vertical motion problems, the y-intercept. So plugging in 0 is a very good idea to figure out your starting point. So your y-intercept is 5, that's the lowest point that the t-shirt reaches, and then the highest point is going to be 86 feet, which we just calculated over here with the vertex. So the way you would actually represent your answer is using an inequality. h is less than or equal to 86, but it's also greater than or equal to 5. And that is the range of this function. So basically, in conclusion, you need to understand that when the t-shirt is launched, it's going to follow a parabola that is upside down. At some point, the axis of symmetry would be used to represent the time it took for the object to reach its maximum height. And then the vertex, when you plug in the axis of symmetry, is going to tell you what that maximum height is. And most of these problems follow the same progression. Lastly, just to actually model what is going on in this specific problem, it's a good idea to be able to imagine what's really happening here. Basically, you have your h and t axis. You have your starting point, which would be at 5 feet. That would be right down here. And then it will end. It says in the problem that the t-shirt is caught 35 feet above the court. So that means its end point would be right over here at 35. And there's the 5 for the starting point. You also have a maximum height of 86 feet, which you can see right there. And then the axis of symmetry at 2.25 seconds. And as you can see, the 86 corresponds to the maximum height. So let's talk about a quick summary of what just happened here, and then we'll be all done with this. We have been discussing vertical motion, and the main idea is that an object will go up and then it will come down. Your time will begin at 0. We are typically not dealing with all the negative areas of the coordinate plane with the vertical motion model, because time is positive, height is positive. So your maximum height needs to be calculated, and then you also need to calculate how long before the object will reach its maximum height. The maximum height will be the vertex, and then how long will it take to reach the maximum height? Well, that will be the axis of symmetry. So over here on the graph, the vertex would be up there at the top, and then the axis of symmetry would be cutting it in half. So another major idea, when an object hits the ground, the height is going to be 0. That's something to keep in mind. Like in the first example with the pebble, we had to set the height equal to 0 in order to figure out at what time that happened. You're not always asked this question, but when you do, you make the height 0. And then lastly, be able to model the situation in your head, be able to imagine it, visualize it, be able to demonstrate what's basically happening. Drawing a picture will really make this material easier to comprehend. So that's it, guys. That concludes 9-2. Stay tuned for the 9-3 video. This was vertical motion, and I'll see you guys in class.